All right, well, welcome to my lecture on data wrangling. You're going to need this for part of your homework. So when you should all have this R file, data wrangle.r, and most of you will need to run this very first line. But since I've already installed the package, I'm going to comment it out. Um, to load in the library and use its content, which is just data sets, I'm just going to hit enter and it's there. Once you do that, you can see this case 1202. It gives you a ton of data. I don't want to see all the displays of data. So in R, there's this command, which is just the head command. It gives you just a little snippet of your data so you can see what it looks like. So there, it's a trim version instead of getting all 93 data points. You could write this every single time, rows 1 through 6, and I could change that to rows 1 through 8 and get the first 8 entries of the data. Okay, or I can change it back to 6 and I'll get the 6th. They do the same thing. I prefer to use the head command. It's just a little bit easier. Okay, if you prefer to see the last little bit of the data, you can see the tail command. Okay, and of course, line 8 is a lot more general. You can see any little snippet of data. Okay. Now, if you want to find out, like, what is this case 1202, you can run that, and to the right here, I have this data set, and it's about sex discrimination in employment, and the variable of interest is going to be this B-sal for us, the annual salary at time of employment, or starting salary. Okay, and then we have all this other information. For our purposes, we're going to ignore salary 77, but we have information such as sex, senior, age, education, experience. It gives you the source and the references, and we see that these variables such as sex, senior, age, education, experience, they appear as the columns of the data. Okay. Now, if I want to select one of those columns, I can do this. Okay, that's one way, or you can use the $sign, or I get the same thing whether I use B-cell or I use $sign. Okay, it gives me 50, 40, 50, 40, it ends there. I'm not going to check all 93 entries. I could also select the column to which it appears, which is the first. Okay, now there's another very nice way to access the data, which is this attach command. Okay, and now I can just refer to the columns by their name. So I could do B-cell, I could do sex, it gives me the gender, I could do experience. Okay, it gives me all of those things. Okay, and it's just a lot more convenient if I attach my data, but you don't have to. Now, this is going to be absolutely essential right here. Subsetting, sorting your data. Okay. So for us, I have this goal, which is select only the data that is female base salary. And for us, we're going to use this which command. It selects data based on logical conditions. Okay. Now, this which command, it returns the indices. So it returns the index, which is this leftmost column, which doesn't have a name. It's right here. So like that 1, that's the first data point. That's the row which it occurs. This is going to be 3, so it's going to return various rows for which the sex is going to be female, so it won't return any of those, but return 15, 16, 17, 18. And it returns a list or a vector, to be more precise, for which these rows occur. Okay, so let's just go over this which command. So in this which command, I have a logical condition. The logical condition is this sex variable, and I need it to be female, and I put it in quotes because it is a string. Okay, if it was numeric, I'd put a number and I wouldn't have to do anything else. Okay, so it's which the data of case 1202 has a variable, that is the column of sex, has the outcome, that is that. Okay, so let's do that. Then I'm going to print what it stores. You can see it returns 15, 16, 17. If I go back up here, well, 15, 16, 17, that's the very first one which has female, female, and so on. I'm going to guess 17, 18, 21. All these below are going to be included. Okay. So it gives me the columns. It doesn't give me the data. If I actually want to get the data, I have to do case 1202. Then this is saying, give me these rows which correspond to the female index. And I put the comma to indicate, give me all the columns. Okay. So that's very important, that comma. So there's case 1202. And now I've accessed the data, all of the data, and every single outcome of the variable sex is female here. Okay. Here's another way which I can do it. So notice one thing that I haven't done is I haven't accessed case 1202 starting salaries. So if I wanted starting salaries of females, I can do bsal. And now I have that 5100, 4800, 5280. And if I go up to my data set, 5100, 4800, 5280, those are the exact same values. Okay, and I'm going to guess the last value is 5220, and that's right there. Okay, so I can access my data like that, or I can do bsal, and because this is just a vector, I don't need anything else. I can just do female.index and it comes up, and I get exactly the same data right here. And in fact, I can do other things, like I can do median of this number right here, and it doesn't matter which one I put in, it'll still give me that value. I could compute the average, which is the mean, and I can get the median and the mean, and I can compute them for the female salary. I could also compute variance and standard deviation and all those things. Now, I want to show you a few other things, which is I can use the subset command on more than one variable. So the logical operators, I can do not equal, equal, and, or. So I can do age or education, and I can select individuals whose education level is less than 10 and whose age is less than 400. Remember that age is the age of the employee in months. Okay, so remember that. Okay, and there's the index. That was with an or. If I can also do a case 1202 for which the education level is less than 10 and the age is less than 400. logically we'd expect less people with this AND command. Remember, we're turning indices, so let's see if that happens. Because if we look at the Venn diagram, this is the intersection. The previous one was the OR. So only 3 people had the AND condition. Okay, but these many people had the OR condition. Then if I want to access the data, we can do that here. Okay, and let's do it for the OR. Age dot education, and we'll do OR, and we'll select all columns. So here we go. That would be the OR command. So let's see. We want education less than 10 or age less than 400. So this first one has education of 15. It doesn't meet the criterion, but look at the age. It's less than 400. Age is less than 400. Less than 400. Okay. So here the age is more than 400, but we have an education of only 8. Okay. Now, here's a few graphical displays of data, and this corresponds very well with the chapter. One of the basic things you can do is you can do a histogram, and it appears on that right. So I need to reset something. Par mf row equals C11. Here's the histogram of salaries, and it doesn't look completely normally distributed. It looks a little bit skewed, right? Because there's way more there than there are there. But other than that, it seems relatively normal. It's hard to assess. Something else that you can use to assess if something is normally distributed, if you're asking specifically for normally distributed, you could do that. Okay. And that is a QQ line, a QQ plot, and we also need the QQ line of B cell. And that's very important because if the data lies on the line, approximately on this line, we would say visually it looks to be normally distributed. And I say we're about right, except this one point. That could be an outlier. It could be within normal, like every now and then you have a observation that is an outlier or just a little bit too weird, right? That line right there, that actually happens to be the CEO. Then you have some people that are paid a little bit like just too, a little bit too far from the line, like these points right here, but it seems to be relatively normal. If I had to go based on this plot, I would say that the data is approximately normally distributed. Not perfectly, but approximate. Okay. So the QQ norm and QQ line are specific for normality. Now, the histogram I made, it had, all I did was one command and it chose everything for me. Let's go back to it. It says histogram of B cell, so I can change what appears there. I can put a label there, and I can do histogram starting salary. It's just a label. I can change the x-axis to be say starting salary instead of B cell, and y, that should be frequency. Okay. Then I can give color to the borders, I can give color to the bars, I can change the limits on the x-axis, I can change the breaks. This is actually very important. 4. I can change that to be whatever I want. Okay, but your book has guidelines for what it should be. I would say no less than 5 generally should be the breaks, but let's run it as it is. Okay, so there's the histogram. and it has 4 breakpoints. Sometimes the computer overrules because it just says the breakpoints aren't enough or it needs to be some other number. Let's change it to be 5. Let's see if that changes anything. Nothing changed. Let's change that to be 8. So here I increase the number of bins here. And it looks less normal here. I could change this some more if I wanted. The computer automatically selects the best number to put here. So if you leave this breaks off like that, you don't have to do anything. But you might want to leave it, you might want to specify it sometimes because the breaks can change the shape or the distribution that you believe the data to belong to. Okay. Okay. Now I can do histograms of female wages. So that's my female data. Sorry, a typo there. And I don't need anything there. And this will be my histogram. And I'll put female starting salary. And it didn't like something else that I did. I don't actually need that. So there we go. There is our histogram. Okay. Now, other things in your book that we could do is we could do a stem and leaf plot. I call that the sleepy histogram. It appears down here. Okay. And it shows me that here's most of the data, and look, there's the CEO. There's one person who makes that much money. Okay. Then I can compute the median of the base salary. I can do the summary, which will return the minimum, the first quartile, the median, the third quartile, the max. When you do this, you may get different answers than by hand, just FYI. Okay, I can do the interquartile range, which would be the third quartile minus the first quartile. I can do a box plot. That's one of the most important plots. Notice it looks symmetrical, so that is very important because if it wasn't symmetrical, it couldn't be normally distributed. Okay, and I can use, this is the ogive plot or CDF plot. So this is the ECDF command, empirical cumulative distribution command, and I'm going to try and find the 80th percentile. So I put a line at 0.8, and I don't know. So I look for where I think the line would approximately cross this. It looks to be about there, so I have to estimate that number. Maybe 5,600 would be the 80th percentile. So I have to read it off of the x-axis. So about 5,600 or so. Okay, that's a reasonable estimate for the 80th. Then I already went over this QQ norm and QQ line, so I won't do that again. But that's just a little bit of breakdown. So there's 2 stages to this. One is obtaining the data, wrangling the data, and the other one is just doing the visual displays. So there are two aspects of this, and you'll be asked to do a little bit of both.